In this tutorial, we will learn how to create a lamp or the curves for a lamp to take it to the laser cutter. We will be able to spread them out and make them ready to send them to the machine. We will be able to change some parameters. Some of them will be the height of the base, the amount of blades that we want, the angle of the blades, the thickness of the material that we are going to use, and we will also be able to change the shape of the curve that we're using, so we can change the whole design in the blink of an eye. I hope you enjoyed. So the first thing I did was creating a curve in Rhino. It could be created in Grasshopper, but I think for this task, Rhino is better. We can put any shape we want. We will actually be able to change the shape as we want as soon as we add it to the algorithm. So the first thing that I'm going to do is bring it to Grasshopper with the param of curve. Okay, and I'm going to leave it there for now. I'm going to change the view to perspective, and I'm going to create the base of the lamp. So to create the base of the lamp, I'm just going to create two circles. And I'm going to put them, I'm going to define the height of this base above the ground or the table. So I'm going to create a point that is going to be, we can change that value whenever we want, but I'm going to create a panel 75 millimeters from the surface. Okay, and I'm going to put one circle here and the other one here. And then I'm going to define the size of the outer circle. That's going to be also a fixed value that I'll be able to change by entering it in the panel. Let's say, for instance, 85 millimeters. And then I'm going to create the inner circle. The inner circle is going to be is going to depend on the size of the socket, of the bulb socket. So we need to measure that. For now, I'm just going to put a value of, let's say, 40. But we know that when we get the socket, we'll have to measure it and make that value according. So the next thing that I'm going to do is I'm going to create some boundary surface. And then I'm going to extrude that on the z-axis or on the z direction. And then I'm going to define the thickness of the material I'm going to use. For now, I'm just going to use 3 mil, but I'll be able to change that. Okay. Okay, and that's going to be the base of our lamp. Okay, the next thing that we're going to do is we're going to spread this curve around that base. Okay, so for that, I'm going to create a circle that is going to be on the ground or on the XY plane, but it's going to be the same size as the outer circle. Okay, and we're going to create that circle so we can put perpendicular frames along it. And we are going to be able to control the amount of frames, which are going to be the blades or the repetition of that curve, of this curve along our object. I'm going to put now less. And then I'm going to orient my curve. Okay. So the geometry I want to orient is my curve. My A is going to be the source, so my curve is in the plane XZ. And then my target is going to be this one. So I'm going to turn this off and turn this off. Okay, so I have my curves, and I can change as many as I want. Okay, now I'm gonna put or make a volume out of them. So I'm gonna create surface, a boundary surface. And then I'm going to extrude those surfaces. So for the extrusion, I'll need a vector, and that vector needs to be normal or perpendicular to each of those surfaces. So for that, what I'm going to do is get the amplitude component. And if I connect a face, so the amplitude component needs a vector and a number, okay? That's going to define how much I'm going to extrude this object. So the amplitude is going to be the thickness of my material, which is, I said it here, is going to be 3. And then the direction, if I connect a flat surface on the vector, okay, what it does, it just gets the normal vector to that flat surface, and yeah, it's extruding it in that direction. So normal to each surface. But we have a problem. Well, it's not a problem, but we have a little detail here. We're extruding in one direction, but I want each of them to be centered on each of those frames. Okay, so what I'll do is just move each geometry okay, and I want to move them in the same direction, so I'm going to get an amplitude vector, which is going to be defined by these surfaces as well. But the amplitude is going to be the division of -2 of the thickness. That way, I'm just moving those surfaces. I'm not extruding them. I already extruded them before. I'm just moving them half of their thickness to the other side of the extrusion, let's say. Okay, so now I have my two groups or my two volumes, which are the blades and the base. I need to make sure that they are intersected with each other. If I move the position of my curve, then the position of those blades is gonna change. So I need to make sure that they are being intersected. Okay, but I can play with that if I want. Okay, so now I'm going to organize a little bit our algorithm because we're going to have a lot of stuff here. So I'm going to create a group here. This is going to represent my base. And this is going to represent the blades. That way we have it all well organized. And I'm going to get a param to keep organizing this for geometry. So I have all of my geometry here, or the blades, and then another one here. That way it's a little bit more, it's a bit tidier. Okay, the next thing that we are going to do is create the gouges or the fittings to assemble the lamp, the blades with the base. So for that we are going to find the intersection, okay, and for that I'm going to go to intersect and I'm going to go to brep. Okay, I'm going to find the intersection of those blades with the base. So if I select it, you'll be able to see all of those intersections. The next thing that I'm going to do is I'm going to create a bounding box with each of those curves. So I'm going to connect it here, and you'll be able that those boxes are aligned to my universal coordinate system. And I need them. You'll see that we have another input on the bounding box that will help us align those planes to whatever we want to connect it to. So if I could take a cable out of the frames, I connect it to the plane, okay, I'll have something like this because I'm connecting a tree, okay, with a list. So what I'll do is just right click on my list and graft it. And that's going to create those boxes which I'm going to use to extract material from my base and from the blades. So to do that, I'm going to create, I'm going to turn this off, but I'm going to need a Boolean difference. Okay, so I can take material with those boxes from my blades and then from the base. Okay, so if I do it just as it is now, okay, it's not going to work because then I'm going to have an empty space and they're not going to be sitting on each other. So what I have to do is just move those boxes or those volumes outwards of the base and then inwards of the base, so I can take half of the material from the base and half of the material from the blades. This is going to make more sense when I do it. So I'm gonna, okay, let's carry on. So to move those boxes, okay, I'm gonna go get the move component, and I need to move those boxes along a vector, okay, which is gonna, or I'm gonna create it with the amplitude component. Then those vectors, to create a vector, I can use a face as I showed you before, or I can use, for instance, a line. If I can get a line, okay, where those objects are being intersected, then I can move those boxes along this line and then make the volume difference. So what I'll do is just get again the brep component, okay, and now I'm going to find the intersection of this surface with this surface right here. And if I select it, you'll see that this time I have lines, okay? And those lines are going to determine the direction of this vector that I'm going to use to move those boxes. So the distance that I want to move those boxes is going to be half of the length of those lines. So I'm going to get the length component. I'm going to connect it here, and then I'm going to divide it by 2. And then I'm going to connect it here, and then I'm going to connect this here. And you'll see that I'm moving those boxes outwards of our base, okay? So next thing that I'm going to do is that I'm going to take material from my base with these boxes. And what's happening here is that I'm combining a tree with one item, so it's just giving me as many objects stepping over the other on the same place as I have branches. So what I'm going to do is just flatten this. And you can see that my base already have the gauges, the fittings. With the blades, I need to do exactly the same thing, but I just need to move my vector to the other side. So I'm going to go to move, and I'm going to add a negative. So if I connect this here and then connect this here, okay, and then connect my geometry, you'll see that now I have the boxes inwards, okay? So I need to make a volume difference again, and I'm going to be removing material from my blades, which are this one. And here again, I have a problem with the tree and the list, so I'm just going to flatten this. And now you can see, I'm going to start turning things off. And then these two, I'm going to group them and turn them off. And then all of this, I'm going to make a group out of it again, which is where I created the fittings. And these two, I'm going to group it, which is my 3D geometries, my proper 3D geometries. So now you can see that the fittings are properly made, and their size is going to depend on the thickness that I put at the beginning of my algorithm. Once we got this, what we need to do is get the curves or extract the curves that we are going to send to the laser cutter, okay? So we got already the 3D shape, okay? What we are interested on are the curves of those faces of our object, okay? So to get the curves, what I'm going to do is I'm going to deconstruct. First, I'm going to get the curves from the blades, okay? And then I'm going to get the curves or the curve, yeah, the curves for the base. So I'm going to deconstruct it, and I'm going to work with the faces, okay? And each of those blades has several amount of faces, okay? What I need is the biggest or the largest face of each. So what I'm going to do is get the area component, so I can measure the size or the the area of each of those faces. I'm going to turn this off, and then I'm going to sort that with the sort list component. So if I connect the areas here and then the faces here, this is going to organize my faces from smaller to bigger, okay? So what I'll do is just going to reverse that list and then get a list item. So I get the first item of each of those lists. So if I select this, you'll see that I'll get the biggest face. That's what I'm doing here in this little algorithm here, okay? Once I have defined what my face, my main face is, my main faces are, I'm gonna get the edges of those faces, okay? And that's just gonna give me a group of curves that I need to join. Once that those curves are joined, so here, we need to spread them on the X and Y axis. So for that, we're gonna use again the orient component, and the source of my orientation is gonna be the frames from the beginning. This one's right here. And I'm looking at it like that because I need to flatten it again. And the other thing that I'm going to do is just spread them. They are all sitting above each other, so I'm going to move or spread them along the x-axis. And for that, I'm going to use a series of this amount of elements with the least length component. I can make the length of my series, and then the step is gonna be the separation of each of those curves. Let's make it 100. And now we have the blades, the curves of the blades to send them to the laser cutter. And for the base, I'm going to do something very similar. So I'm just going to copy these. The only difference is that my source, well, I don't need any of these. And my source is going to be the X and Y axis. That is going to be in this point. So it is already sitting there. I'm just going to move it on Y. And that's it. We have already our curves. That is actually what we want to bake and send to our laser cutter. So we can always go back to the beginning of our algorithm and change the parameters that we made. For instance, the number of blades. Okay, and then we will have the curves straight away. We can change the height of the base. We can change the size of the base. And we can even change the shape of our initial curve. Okay, for instance, we can change the control points, or we can just create a new curve. Okay, now let's assume if we do that, I can go back here and make the step of the series a little bit higher so they're not overlapping. Okay, and now we have a different lamp. So let's assume now that we want to add a slight rotation to our blades in order to avoid the bulb to be seen. Okay, so to do that, I'm gonna turn this off. Actually, I'm going to disable it. That way we can run it quicker. And then I'm gonna turn this to back on. And then I'm gonna reduce the amount of blades that we have. Put it, for instance, 16. Okay, so if we want to add a rotation, then we would have to add it somewhere here. So what we want to rotate are these frames. So I'm gonna get the rotate component. What I want to rotate are these frames, and then where or how do I want to rotate them? I'm gonna get a slider. This one I'm gonna change it to degrees, so I can connect a slider that works with degrees. And I'm gonna create a slider that goes from 0 to 60. So you can see those planes from that component right down here. And if I move that angle, I'm just gonna be moving those blades along the base. But what I want to do is spin them on their spot. So what I'll do is just create or get an XY plane axis, okay? And then the origins are going to be the places where those frames are sitting at. So what I'll do is just get a divide curve component, and I'm just going to divide this curve into the same amount of points as I have frames, and then I'm going to connect those points here. So if I turn this off, and again I move this, turn this off as well, you'll see that now those frames are moving on the same spot they are on. So what I'll do is just, I'm gonna disconnect, or actually I'm gonna disconnect this from here, and I'm just gonna reconnect this here, and then I'm gonna connect this here. Now I can turn this off, and I can turn this off as well, and I'll enable again my proper 3D geometries. And if I come here and move that slider, I will add that rotation. If I go to the top view, it'll be easier to see. And you can see that I already have my curve adapted to that rotation. So I can come here, let's put, for instance, 30. And you can see there's more rotation. Okay, so same with that, I can just play or do a lot of different stuff, like changing maybe the scale of those curves along the base, etc.